Hello, this is Mr. Gummel with the 3.1 Part 2 Polygon Congruence lesson. Today we ask ourselves two very important questions. Is congruency transitive? And also, is it reflexive? See, the thing is we've encountered several relationships already before, such as equality, greater than, and less than. But now we have a new relationship, the relationship of congruence. We cannot then just jump to the conclusion that these also have the same properties that equality has. We have to consider, does congruency carry properties of transitivity and reflexivity with it as well? So let's then review, let's remember what is polygon congruence. Polygon congruence, remember, is two polygons in which they can produce the exact same list, which means all their corresponding sides and angles are equal. If they can produce those exact identical lists, then we can call those polygons congruent. So yes, we know that equality is a true relationship, but does congruence carry the same properties that equality does? Again, specifically transitivity and reflexivity. Let's start with reflexivity. If, let's say, I give you a polygon, the question, when I ask the question, is congruence reflexive, I'm really asking the question, is that polygon congruent to itself? Well, of course it is. I can produce identical lists from that same polygon, which means all of its sides and angles correspond with itself, which then means, yes, this polygon, or the property of reflexivity does apply to congruence as well. You are going to prove this in the problem set. It's a very simple proof. I will even walk you through the statements and you just fill in the reasons. So yes, every polygon given is in fact congruent to itself. Now let's consider transitive property. Let's consider the transitivity of congruence. Let's say I give you three triangles. One is ABC, the other is LMN, and the third is RST. Let's say I say ABC and triangle LMN are congruent to each other, as well as triangle LMN is congruent to RST. Well, what would then follow about triangle ABC and triangle RST? Well, it would immediately follow that the two would have to be congruent, right? I mean, let's then break it down. Let's say we pick one pair of sides to follow through. Let's say we pick the side AB from our triangle ABC. Well, from the first congruency statement, ABC is congruent to LMN, we know that AB and LM have to be equal to each other. From the second congruent statement, we know that LM would have to be equal to the side RS. Well, then what would follow from those two statements? If I know AB is equal to LM and LM is equal to RS, it would immediately follow that AB and RS are equal by the transitivity of equality. So we're going to use the transitive property of equality to help us prove that the transitivity of congruence is also a viable relationship. Well, we've done that for one side of our triangles, but remember we need all corresponding sides and angles to be equal to each other, basically producing the same list. So we could do this for the same with all of the angles and with all of the sides. Since we've done that, that means triangle ABC and triangle RST produce the exact same list. And because they produce the exact same list, that means we can define them to be congruent. So yes, we've established that the property of congruence, or the property of transitivity, does apply to our relationship of congruence as well. So we're going to add then to our set of postulates the reflexivity of congruence and transitivity of congruence. All polygons are congruent to themselves, and if the first polygon is congruent to a second and the second is congruent to a third, then the first and third polygons have to be congruent. This again will be proven by you in the problem set. I have provided a proof of this. I've given all the statements. You are going to help me fill in the reasons. This is not a very long lesson today, as you can see. If you do have any questions, however, you are to email me. Please be working on the 3.1 Part 2 worksheet, and with that, be good and do good.